Welcome to another deep dive with us. And today, we're going deep into the quantum realm.
Ooh, that sounds exciting.
It is. To uncover the story of a physicist you might not know, but should.
Okay, I'm intrigued already. Lay it on me.
Pascual Jordan. His work is, woven into the fabric of modern physics. But not a household name.
That is interesting. How does someone so crucial to quantum mechanics stay kind of obscure?
Right. Even with a name as memorable as Pascual Jordan.
Okay, you've got me hooked. Who's going to help us crack this case? Where are we getting our info?
We've got a fantastic essay as our guide. Pascual Jordan.
Mitbegründer der Quantenfeldtheorie.
Mitbegründer der Quantenfeldtheorie, Ketchy. Who wrote that?
It's by Jörg O. Schneeppert. And from what I've gathered, Jordan's life wasn't just equations and labs.
Oh, there's more to it.
Yeah, Schneeppert suggests there were complexities, which honestly makes the story even more interesting. Not just the science, but the man behind it.
Totally. The human side of science is always fascinating. But before we get into all that, maybe we should, set the stage a bit, right? Absolutely. What was happening in physics that made the quantum revolution, inevitable?
Okay, imagine this. You're trying to explain how a smartphone works, but using the physics of steam engines.
Okay. That's a bit of a stretch.
Exactly. That's what it was like back then. Classical physics worked great for big stuff, the world we see. But zoom in to the level of atoms. Total chaos.
Give us an example, something that really stumped those classical physicists.
Okay, black body radiation. Heat a piece of metal. It glows, right? Gets hotter, brighter. You get that.
Sure.
Well, old school physics said the light should get infinitely intense as it heats up. Clearly, that's not how it works.
No kidding. Everything would be exploding with light.
Right. That's where Max Planck steps in. He's like, hold up. Energy isn't smooth. It's in packets. Quanta. Bam. Quantum physics is born.
Planck, the trailblazer.
Yeah.
So Pascual Jordan walks into this world where physics is being turned upside down.
Precisely. Planck was just the start. Einstein's explaining the photoelectric effect, light's a wave and a particle. Then Bohr's got the atom, electrons in specific levels. It was a wild time.
Fertile ground for some new ideas, for sure. And speaking of new, Pascual Jordan enters the scene. Born in 1902, Schneeppert tells us. Not in a physics lab, though, right?
Nope. Hamburg, Germany. Not exactly a quantum physics hotspot back then. But Schneeppert really emphasizes how, even as a kid, Jordan was hungry for knowledge.
So not just a math whiz, a curious kid overall.
Totally. Math and science, sure. But also music, art. His mind wasn't boxed in.
Multifaceted. So this well-rounded guy ends up at Göttingen University. Wasn't that the place to be for physics and math at the time?
You got it. Göttingen was a magnet for brilliant minds. And it's there that Jordan meets, drumroll, Max Born, big deal professor. And also Werner Heisenberg, young hotshot physicist with radical ideas.
Oh, wow. Okay, so we've got a trio of brilliant minds smack dab in the middle of a scientific revolution. What's the dynamic like?
Imagine this. Heisenberg's got the crazy intuition, seeing how particles act weirdly at the atomic level. Born's the experienced one, all about rigor and math.
And Jordan, where does he fit in?
Schneeppert describes him as the mathematical glue. He takes Heisenberg's wild ideas and makes them into a solid theory.
And that theory is?
Matrix mechanics.
Okay. Matrices? Those grids of numbers. Not exactly known for their simplicity.
They aren't, but they were perfect for describing this new quantum world. See, in classical physics, it's easy to know a particle's position and momentum. At the same time, no problem.
Makes sense.
But in the quantum world, those two things are, linked. Measure one, you mess up the other, can't know both perfectly.
So it's like trying to catch a shadow, right? You reach for it and it changes shape.
That's it. And Jordan, he's the guy who figures out how to express that mathematically. Enter the famous non-commutative equation, Q, P, 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 Q.
Oh boy, that's a lot of letters and symbols. Break it down for us non-physicists. What's the big deal here?
Basically, it means the order you measure things in matters. Position, then momentum. Not the same as momentum, then position. That's wild. Classical physics never had that problem.
So measuring messes with reality at the quantum level.
It is. And Jordan was key to figuring that out.
So we've got Jordan helping to create one of the foundational theories of quantum mechanics. A theory that says reality isn't what we thought it was.
Exactly. But as Schneeppert points out, he didn't stop there. Jordan goes on to develop something called Jordan algebras.
Hold on. He invented a whole new type of math.
He did. Basically a math specifically for quantum stuff to handle all the weirdness.
Okay, impressive. But are these Jordan algebras just some mathematical curiosity, or do they actually get used today?
Oh, they get used.
Yeah.
especially in, surprise, quantum computing. You know, the next big thing, supposedly solving problems no regular computer can.
Yeah, quantum computing is kind of sci-fi to me still, but I know it's a big deal.
It is. And Jordan, back in the 1900s, he was laying some of the groundwork for it. His math helps us understand and mess with quantum systems.
Wow. So this guy goes from math whiz kid to quantum pioneer, inventing new math along the way. Sounds like a success story. But Schnepf did hint that things weren't all smooth sailing.
You're right. There's another side to Jordan's story, and it's not so bright.
Okay, well, let's dive into that then. Understanding a person means knowing the good and the bad, right? Especially when it comes to someone like Jordan, who had such a big impact.
I'm with you, so ready for the twist.
Absolutely. Hit me with it.
It all starts in the 1930s, the rise of the Nazi regime in Germany.
Uh-oh. That casts a pretty dark shadow over a lot of lives. How did it affect Jordan?
This is where things get complicated, and we need to be careful how we talk about it.
I'm ready to have that conversation. To understand Jordan, we got to understand this part of his life too, even if it's uncomfortable.
You're right. It's part of the whole picture. So let's talk about Jordan and National Socialism. Here's the tough part. According to Schnepf, Jordan joined the Nazi Party in 1933.
Wow, that's, hard to square with the image of the brilliant scientist. What led him to do that?
Schnepf doesn't say for sure, but he shows that Jordan was actively supporting their ideas. Not just a member, a vocal one. Even tried to say quantum mechanics was German science.
Yikes. Trying to tie groundbreaking science to that ideology. That's disturbing.
It is. And of course, this was a time when many scientists, especially Jewish ones, were being persecuted, forced to flee.
Right. So Jordan's choice wasn't just an abstract idea. It had real consequences for people.
Exactly. And it especially hurt his relationship with Max Born. Born was Jewish, had to escape Germany for his safety.
Oof. I can't imagine the betrayal Born must have felt. His colleague embracing the very thing that was threatening him.
It was a huge rift. Schnepf makes it clear that this decision really damaged Jordan's relationships and cast a shadow over his career, no matter how brilliant his science was.
It's a tough reminder that brilliance and good morals don't always go together.
Sadly, that's true. And it's what makes Jordan such a complex figure. So much potential, but this huge flaw, too. How do we reconcile that?
That's a huge E question. One we're going to have to keep exploring in part 2 of our deep dive. This conversation's definitely not over yet.
Agreed. There's so much more to unpack about Jordan's story. The highs and lows, it's all connected. So yeah, we left off on a pretty heavy note, Pascual Jordan and his involvement with the Nazi regime.
Yeah, tough to think about that alongside his brilliant work in quantum mechanics. So what happened after the war? Did his past, catch up with him?
It definitely affected his career. Schnepf says he was suspended from his academic job for a while, because of the Nazi thing.
Makes sense. Though some folks who were really involved got off pretty easy back then, didn't they?
It was a mixed bag, for sure. But in Jordan's case, he was allowed to teach again later, even became a professor in '53 at Hamburg University. But I never quite got the same level of, international recognition as some of the other big names in physics.
Yeah, that shadow kind of lingers, doesn't it? It makes you think, how different could things have been if you'd made different choices? Do you think his actual scientific work has been, downplayed because of this stuff?
It's hard to measure that, for sure. But I'd say it's likely his Nazi affiliation influenced how people saw his work and maybe what opportunities he got.
Schnepf doesn't go deep into that, but it makes sense, right?
Yeah, it's hard to separate the person from the science sometimes. So that brings up the big question, doesn't it? How should we think about someone like this? Brilliant, but also made morally awful choices.
That's the million-dollar question Schnepf kind of leaves us with. And it's tough. No easy answers.
Right. Can't just ignore the bad stuff. But also, his work is important. How do we balance that?
I think it's about honesty, right? We acknowledge both sides, celebrate the achievements while condemning the choices.
Yeah, holding both those ideas in mind at once. Not saying it's okay, but understanding it all as part of who he was. Exactly. Schnepf's essay doesn't shy away from the full picture, good and bad. And that's what makes it so valuable. It forces us to think about the whole person, not just the parts we like.
It's like a reminder that scientists, even the super geniuses, aren't perfect beings. They're affected by the world around them, same as anyone else.
Right. And sometimes those influences lead to bad places, like with Jordan. But his story also shows that science itself, the progress, it's not separate from all that human messiness.
Yeah, the personal stuff, the politics, it all mixes in. So where does that leave us with Jordan's legacy? What do we take away from all this?
For me, it's about being critical, you know. When we look at history, we don't idolize scientists or dismiss them because of their flaws. We try to get the whole context.
You understand, not just to judge, right?
That's it. And with Jordan, there's so much to understand. The brilliance, the mistakes. Schneppat's essay gives us a starting point, but it raises more questions too, I think.
Yeah, this deep dive feels more like the beginning of thinking about these things, not the end.
And that's good. It's what these deep dives are for, to get us thinking. So what's striking is that even with all the controversy, Jordan's work is still out there, making an impact.
Yeah, those Jordan algebras we talked about, still being used, even in cutting-edge stuff like quantum computing.
It's amazing. Ideas from almost a century ago, now shaping the future. It shows you how powerful science can be, but it also makes us think, right? About the context of those discoveries, the ethics.
Because Jordan's story is kind of a warning too, isn't it? Brilliance doesn't equal goodness. We got to be careful. Make sure the science is used for good, not for harm.
Absolutely. So for our listeners who are now totally hooked on Pascual Jordan, want to learn more, where should they start?
Schneppat's essay is a must-read, of course. Pascual Jordan, Mitbegründer der Quantenfeldtheorie. Gives you that solid foundation. And I bet he's got more stuff in that bibliography too, right? For digging deeper.
He does. And beyond that, there's tons of stuff on quantum mechanics in general. Books, articles, the works of those other big names like Born and Heisenberg gets you into that whole world Jordan was part of.
A whole rabbit hole to go down. Sounds like fun to me.
It is fun. That's what makes learning so cool, right? Discovering these stories, these connections, it's all out there waiting to be explored.
Well, on that note, I think we've done a pretty good job of unpacking Pascual Jordan, right? His brilliance, his flaws, his complicated legacy. It's a lot.
We've only just scratched the surface, but yeah, it's been a good start. Hopefully got our listeners thinking, you know, about how we see scientists, how science fits into history.
Because it's not just about the equations, it's about the people, the choices they make. And those choices matter, even today.
That's right. Science is a human thing through and through. And sometimes that's inspiring, sometimes it's scary, but it's always worth understanding. Man, even after all that, it feels like we just dipped our toes into this whole Pascual Jordan thing.
I know, right? Schneppat's essay really packed a punch. So much to think about. Jordan's life, his work, it's all connected to bigger stuff, you know?
Totally. These deep dives always show you that. One person's story can open up a whole world of ideas, history, even...
It makes you wonder how many other Jordans are out there. People who did important things. But we've kind of forgotten about them.
Oh, tons, I'm sure. History's full of those hidden figures. And it's on us to dig them up, right? To figure out how they fit into the puzzle.
Yeah, like each deep dive we do is adding another piece. Helps us see the bigger picture.
Exactly. And with Jordan, what's so interesting is how his story messes with our ideas about science, you know? We think of it as all objective, pure logic.
Right. Scientists in their ivory towers, totally removed from the world.
But Jordan shows us that's not how it works. Science is done by people, and people are messy. All those contradictions and complexities, they're part of it.
It's like science is always happening inside society, not separate from it. So the good and bad at the times, it all gets mixed in.
Absolutely. And that's important to remember, especially in W. Science is moving so fast, technology too. We got to think about the ethics of it all, you know?
Yeah. Make sure we're using this stuff to make things better, not worse. Jordan's story is kind of a cautionary tale there, isn't it?
It is. He was brilliant, no doubt. But that didn't stop him from making some terrible choices. Shows you smarts don't equal being a good person.
Oof, yeah. So we got to be careful, right? Not just pushing science forward, but thinking about where it's going and why.
Exactly. So anyone listening who's like, okay, I need to learn more about this Jordan guy, where should they start?
Well, first off, read Schneppat's essay.
Pascual Jordan, Mitbegründer der Quantenfeldtheorie. It's a great intro. It gets you thinking. And I bet his bibliography has tons of other leads, yeah.
Oh, for sure. Plus, there's so much out there on quantum mechanics. Go deep on the science itself. Read about Born, Heisenberg, Bohr. The whole gang was in on it.
Ooh, a whole quantum rabbit hole to jump into.
That's the fun part. And who knows what LEC you'll find along the way. Science history is full of surprises.
So wrapping this all up, I think we've done a pretty good job of unpacking Pascual Jordan, the science, the good, the bad. It's complicated. We've only just scratched the surface. But yeah, it's been a good start. Hopefully got our listeners thinking about how we see scientists and the impact of their choices.
Because it's not just about the equations, right? It's about the people behind them. Their stories matter.
They do. So until next time, keep exploring, Keep asking those tough questions. There's a whole world of knowledge out there just waiting to be discovered.
That's what these deep dives are all about. And on that note, we'll see you next time for another deep dive into the fascinating world of knowledge.